River discharge refers to the volume of water flowing through a river channel at any given time, typically measured in cubic meters per second. This flow is a crucial aspect of river dynamics and plays a significant role in shaping the river landscape and influencing flood risk. Several factors influence river discharge, and these can be broadly categorized into physical and human factors. Physical factors include natural elements such as precipitation, geology, and topography, while human factors encompass activities and modifications made by people, such as urbanization, deforestation, and river management practices. Precipitation is a primary physical factor affecting river discharge. When a region experiences heavy or prolonged rainfall, the amount of water entering the river system increases, leading to higher discharge. Conversely, during dry periods, the discharge decreases. The intensity, duration, and type of precipitation, rain, snow, sleet, all impact how much water flows into rivers. Snowmelt, particularly in spring, can also contribute significantly to river discharge, especially in regions with substantial snowfall during winter. The geology of a river basin influences how water moves through the landscape. Permeable rocks and soils, such as sandstone and gravel, allow water to infiltrate and percolate through the ground, reducing surface runoff and potentially lowering river discharge. In contrast, impermeable rocks and soils, like clay and granite, hinder water infiltration, resulting in more surface runoff and higher river discharge. This runoff can quickly enter rivers, especially after heavy rainfall, increasing the risk of flooding. Topography, or the shape and slope of the land, also affects river discharge. Steeper slopes facilitate rapid water movement towards rivers, increasing discharge rates. In contrast, gentle slopes slow down water flow, allowing more infiltration and reducing immediate discharge into rivers. River basins with extensive steep areas are more prone to rapid increases in discharge and, consequently, higher flood risks. Human factors significantly impact river discharge and flood risk. Urbanization, for example, replaces permeable surfaces with impermeable ones like concrete and asphalt. This change reduces the land's ability to absorb water, increasing surface runoff and quickly directing more water into river systems. As cities grow, the risk of flooding increases due to the higher volumes of runoff entering rivers during rainfall events. Deforestation and land use changes also influence river discharge. Trees and vegetation play a crucial role in intercepting rainfall, enhancing infiltration, and reducing runoff. When forests are cleared for agriculture or urban development, the lack of vegetation increases surface runoff and elevates river discharge, raising the likelihood of floods. River management practices, such as the construction of dams, levees, and channels, can alter natural flow patterns and affect discharge. While these structures aim to control water flow and mitigate flood risks, they can also have unintended consequences. Dams, for instance, regulate discharge by storing water and releasing it in controlled amounts. However, if not managed properly, they can exacerbate downstream flooding during periods of excessive rainfall or rapid snowmelt. Levees and floodwalls, designed to contain river flow, can sometimes fail or be overtopped during extreme flood events, leading to catastrophic flooding. Climate change is an emerging factor influencing river discharge and flood risk. Changes in precipitation patterns, more frequent and intense storms, and rising temperatures contribute to variability in river discharge. Increased frequency of heavy rainfall events can lead to more frequent and severe flooding, challenging existing flood management infrastructure and strategies. In conclusion, river discharge is a critical aspect of river systems, determined by a combination of physical and human factors. Precipitation, geology, and topography naturally regulate the volume of water flowing in rivers, while human activities such as urbanization, deforestation, and river management practices significantly modify these flows. Understanding these influences is essential for managing flood risks and protecting communities and ecosystems from the impacts of flooding. Effective flood risk management requires a comprehensive approach that considers both natural processes and human interventions to create resilient and adaptive strategies for the future.